So let's start with the first type of iterative structure, the while loop. The while loop always has the same overall structure. While, so this is a reserved word, while, some expression, some condition, and then do some code inside of the loop, as usual indented to indicate what's inside of the loop. And the first one that we can do is this one. So let's select this part of the code. Let's run it in this other notebook. In this case, when I run it, I get this result. So I have one variable that is called I, and that governs the loop. While this is the while condition, while I is smaller than 5, I'm going to come inside of here and do this. Print I and augment I, add 1 to I. Okay? So on the first loop, I'm going to come here and I is going to be 0. 0 is smaller than 5, so this is going to be true, and I'm going to come here, print 0, and change I to 0 plus 1. I will move to contain the value 1. Okay, then I will come back here, I will be 1, which is still smaller than 5, and I will come here, print 1, and add 1 to I, so it will be 2, and so on and so forth, until when I get to I4 printed here, then I will be 5, it will no longer be smaller than 5, and it will go out of the loop. Okay. If I change I to 50, then I get a nice long list of 50 numbers from 0 to 49. If I change it to 3, I get, a shorter list with only 0, 1, and 2. Okay, these are examples of the while loop. 10. One thing that you might see in the code is that this thing can be also written like this. I plus equals 1 is the same thing as I equals I plus 1. Okay, so if I do it, I get the exact same result. Okay, we have been playing a little bit with a very simple while loop. Structure is always the same. While some condition is true, enter. And that code inside of the while will probably change the variables in this condition, so that when something happens, in this case I becomes bigger or equal to 10, then the loop stops. Okay, this is one very simple while loop. Because while loops are often governed, managed by variables, we usually have these parts, the iteration index initialization. Okay, so if we have one variable that is going to decide when the loop stops, this, as you can see, is a fixed type of loop. We always iterate the same number of times. Okay, so if we have this variable that's going to decide that, then we need to initialize it outside of the loop and change it inside of the loop, or we will never finish. Let's see what would happen if we did not have this. I'm going to actually comment out this. So now I'm not going to change I. And when I try to run this, I get lots of times 0 printed, and this thing is thinking and thinking because it's never going to leave the while loop. Okay, I'm stopping it. It doesn't want to stop, so I'm going to have to, okay, it stopped after a while. Okay, keyboard interrupt. Okay, basically it entered here, 0 is smaller than 10, and it printed it, and then went on and on and on printing zeros because I had not changed the value of the variable that governs the loop. So usually, if I have one of these while loops, I need an initialization of the variable that governs it outside, and I need to augment it inside of the loop body. The code inside of the loop is called the loop body, and this thing here is the while condition. Okay. in the same way that I did it with a growing index, I can also do a simple while loop with a decreasing index. Okay, so play with this one, but in this case, let's do it. I can start from 10 and then change the variable not to increase but to decrease. And then I will start printing a number 10 and stop once I reach 0. Okay, and if I do that, I print the numbers from 10 to 1. As long as it's bigger than 0, I go on. I could even say bigger or equal than 0, and then I would go downwards and up until down until 0. Okay, so these are some very simple fixed iteration while loops. So far, the 4 loops that I have seen have also all had a fixed number of iterations. It changed it every time, but I decided at some point how many times we would iterate, and we always iterated exactly the same number of times. Here we will see some loops that will not iterate a fixed number of iterations. Okay, for example, we will use random numbers to help us with that. How do we use random numbers? Well, I'm really happy that you asked that question, because that allows me to speak about coding libraries. The reason why we are using Python in this course, it's because it's a very easy to learn language that has a very, very big community. So whenever you encounter a problem, there is probably someone on the internet ready to answer any question that you might have. Not only that, there have been many coders that came before you that have done some code, and many of them have been kind enough as to make some of the code that they made available to us. So every time we code, we don't have to start from scratch, like we were the first person ever to think about programming. We can use some of the code already available, and some of it is available in what is called coding libraries. So whenever we want to do something slightly special, we usually should begin by searching the internet about whether that has already been done before and whether we can use that. In this case, for example, we want to use random numbers, and there is a very conveniently named random library that helps us with that. In this case, I'm going to import from the random library, I'm going to import the randint function, and I will use it to generate random numbers given some limits. Okay, so let's do some looping here using random numbers. Okay, in this first one, I'm going to still do a fixed number of iterations. We will do 3 of them, and we will do them just printing and adding up different numbers that we generate. First, we will generate a random integer between 1 and 10, and then we will print it and add it up, and then get a total sum of the numbers that we have added up. Let's see. So in this case, for example, I generated 4, 8, and 5, and their sum is 17. I could generate 30 instead of 3, and I could get a much longer list between 1 and 10 and a total sum. Okay, so in this case, while it's similar to what we did before, but the behavior is a little bit different, because every time I get a different random number that I get to add. Okay, so I'm using a coding library that very helpfully allows me to generate as many random numbers as I want. Let's do 300. Okay, long list, and yes, one sum here, as many as I can and need. Okay. I can also, as I said before, do while loops that do not have a fixed number of iterations. For example, let's use some code that we did before, the code about conversion of coins. Remember, changing yen to Greek? So let's recuperate our rate variable and our yen and to Greek variables. And what I'm going to do is that I'm going to generate quantities in yen between, in this case, 1 and 350 that I have chosen until I have enough to Greek. Enough to Greek is at least 5,000 to Greek, because that's what I'm hoping to be able to spend on Kushur. Okay, so let's see this in action in the notebook. I can run this, and for example, this time, the first time I initialized it, I already had enough for Kushur. I initialized, let me add print here. Okay, so let's run it. First time I initialized it, I got already enough yen for my Kushur. Let's run it again. This time, the first time I came here, okay, this works by defining this yen and to Greek as 0. The first time that I come here, to Greek is not, to Greek is smaller than 5,000 because it's 0 the first time, and I come here and then I initialize a random number between 1 and 350. Okay, in this case, the first time I generated 189, which when converted to Greek is not bigger than 5,000, bigger or equal to 5,000. So generated this, did the conversion as we had done before, and then reached this if. So we are using an if else inside of a while, and in this case came to this branch, left the if, left the if, came back to the while. Okay, this code is inside of the while, this code is inside of the while and of the if. This is outside of everything, so I haven't yet run this. Then I came back here again, generated the random integer, in this case 69, and did the same route. Finally, third time, I came here, generated 251, and then I already had enough for Kushur. And after, when I got out, I generated, and now I really have more than 5,000, and I can run it over and over again. In this time, I got it at the first try. This time I needed 1, 2, 3, 4, 5. Okay, so for this code, the number of iterations that I do is random because it's governed by this to Greek variable that's converted from something that is random.